Hello everyone. In this video, I'm going to share with you some of the general points to note when handling problems. From the previous videos, you should have learned quite a number of references or properties that related to angles in the circle, right? And in determining which reference or which properties to be used, here are some general guidelines or suggestions. Number 1. When the center of circle is given, then you may think of the following things. Number 1, about isosceles triangle, because when center of the circle is given, then two radii can be drawn, and then you automatically have a setting of isosceles triangle, and these two angles are equal. Number 2, you may have angle at center twice angle at circumference. When the center of circle is given, you need to see if there are two points such that they have lines joining to center and joining to the circumference. Okay? Number 2, when 4 or more points are given on the circumference, you may think of the following. Number 1, angles in the same segment, because when there are 4 points like A, B, C, D, you will have, say, angle AC boy is equal to angle A dot boy. Whether to use it or not, you need to see if we have this kind of crossing AC intersect BD at a point. Number 2, opposite angles cyclic quad. When you have 4 points and there is no intersection point of AC and BD given, but instead a quadrilateral ABCD is given, then you may think of the sum of A and B is 180 degrees, or the sum of X and Y is equal to 180 degrees. Number 3, exterior angle cyclic quad. It's easy for you to consider whether to use this kind of thing, because there should be an outside point that is the extension of one of the sides of a quadrilateral. Okay, and these two angles are equal. Number 3, a diameter or a semicircle is given. Then you can consider the following. Number 1, angle in semicircle. Angle in semicircle means the longest chord of the circle extend the endpoints . Okay, two line segments are drawn from the endpoints of the diameter. Then the angle here is 90 degrees. Number 2, when a semicircle is given or a diameter is given, you need to note whether the center of circle is given or not. If there is, you may need to consider angle at center twice angle at circumference. like this. From 2 points, joining to the center, and from the same points, okay, from the same point here, AB, joining to the center, we have 2 times the angle. And from the same point AB, pointing to the circumference, you'll have x and 2x. Okay? Number 4. Angle which is outside the circle is given. In this case, you may consider the following. Number 1, opposite angles cyclic quad. Because sometimes you may need to bring the angle back. Okay, say for an example like this. When a cyclic quad is given and there's some angle lying outside, you may need to consider this angle with, say for an example, this angle and this angle. Because we will have exterior angles found here and opposite angles 180 degrees. And of course, the same situation, you may think that you should use exterior angle cyclic quad. It's up to you. So if you are given the same figure, instead of using exterior angle to find this, you may move this angle to here. And then you can use angle sum of triangle. Number 3, you may think that, oh, if there's no cyclic quadrilateral given in the figure, but then there's still an angle given outside, then you may need to consider to use exterior angle of triangle. Because sometimes you will be given a figure like this. And then most of the time, you are suggested to move this angle together with this to here. And then you may use the angles property in a circle to deal with this angle. Okay? And finally, number 5. Number 5, when lengths of chord or sides are given, or you need to consider them. Although we have learned some of the properties about chord, that is about the perpendicular bisectors, we have learned the use of Pythagoras theorem, etc. But not all the times it involves the center of circle. And in this case, you may need to consider the following. Number 1, you may need to consider similar triangles. And in the following, I will introduce to you 3 common type of similar triangles to you. Number 1, it happens inside a semicircle. We know that in a semicircle, we have angle in semicircle, which is a right angle. It's a right angle. And what if we choose this point and I draw a perpendicular line to the diameter? due to the fact that this is a common angle between the small right angle triangle and this large right angle triangle. Then the small triangle here and the large triangle here are similar. Then you may need to use corresponding sides similar triangles to help you find out something related to length. And sometimes you may need to also use the area of triangle to help you find the length. Like when this is the base of a triangle, this is the height. And when this is considered as the base, this is the height. Then you have something like the product of these two sides is the same as the product of these two sides. Okay? Number 2, since we have the angle in the same segment, 4 points, if we draw something like this, the angles in the same segment tells us that these two angles are equal. And also, these two angles are equal as well. Then, let me give you some naming here. Suppose AC and boy dot intersect at the point E. Then, triangle A dot E and triangle boy CE are similar. Then you may use the corresponding side similar triangles to help you find something related to lengths. Okay? And number 3 is about something like this. If we draw two lines like this, the two lines intersect the circle at these 2 points, and if I construct a figure like this, then a cyclic quadrilateral is drawn, and then we can make use of the property that exterior angle cyclic quad together with this common angle, then the small triangle here is similar to the large triangle here. So that you can consider corresponding size similar triangles to help you find something related to lengths. Okay, so these 5 things are general notes to you to help you start the question. And then in the next video, I'm going to do some work examples for you to make good use of the points here and the reference. Okay, see you in the next video, and thanks for watching.